Hello, and Michael here, and today I thought I would go over some techniques that you can use to kind of help prevent yourself from repeating yourself a lot, and I kind of repeated the same word quite a lot there. So on this channel I have done a video about actor components previously, but I thought I'd actually go over it in a little bit more detail and actually show you how to create some practical uses on how to use actor components in a way that allows you to essentially create reusable logic. So just before I jump in, I just want to let you all know that I am on Blue Sky, so if you want to follow me on there, the link should be in the description. I also have a Discord, so by all means jump on there if you want to chat about game dev stuff. We're quite a few active members at the moment, which is great. So let's jump in. So I am currently in 5.5. The version number generally shouldn't make too much of a difference. And this is just the third person template, so it's a brand new project, so there's nothing fancy or anything like that. I've not made any changes. So first thing we kind of want to do, I'm just going to go ahead and create a new folder. I'm just going to call this blueprints, the usual starter stuff. And as an example of one of the things that I kind of want to go over, I'm going to see if we can try and squeeze two in today. And that's essentially, let me add a shape. Or a volume even. So let's say we've got this blocking volume over here, and we're going to have a few of them dotted around. Like so. Now these blocking volumes, because they are placed in the level through here, they are technically an actor. So we can add additional components onto them if we wanted to. Now let's say we've got these blocking volumes, and whenever we overlap them, then we want to destroy something. So we've got 3 blocking volumes and we've got 3 cubes, so yeah. Now, it could be that there could be different types of actors and you kind of want the similar sort of behaviour where they overlap and then they destroy something. Of course, the actual action that happens, so in this case the destroying, that could be whatever you want. It could be unlocking a door, changing a material, teleporting the player somewhere, lots of options. But we'll go for the destroy one just because it's a little bit easier to see and visualise from a blank project. So what we're going to go ahead and do is, in the blueprints folder, I'm going to create a new blueprint class, and we want to choose actor component. And I'm going to call this destroy linker. Yeah, there's probably a better name for that. So I'm going to go ahead and open that up. Now, before we actually start doing some logic in there, as an example of what we can do, so with this blocking volume selected, in the details panel we can click add, and we should see that destroy linker in here, and we can add that component to this blocking volume. So now this blocking volume here has that actor component on it, but the one next to it doesn't. So we can kind of essentially use this actor component to create some logic that we can add quite easily to this. That kind of saves us having to create a specific blueprint that we then have to place in the level. Instead, we've created an actor component that's going to have all the logic in it, and we can just place it on any actor essentially. So it kind of makes it a little bit more flexible in terms of how that can be used. Okay, so jumping into the destroy linker, what we're going to do is actually use the begin play. So when the level first starts, we're going to have to do a few things to essentially facilitate what it is that we're wanting to do. So the first one is we can do get owner. And you do want to make sure it's the actor component as the target. So there is 2 get owners. Get owner. Not sure if I'm going to be able to find it. Yeah, there we go. Yeah, so as I mentioned, there is 2 get owners. So one's for specifically an actor, and then the other one is for actor components. You do want to make sure it's the actor component one. If you're using context sensitive, it should normally do the actor component one. Now, what this is going to do is it's going to get essentially whatever this is placed on top of. It's going to that's going to be its owner, and it's going to be getting that. So in this case, when this destroy linker is initialized, it's going to get the blocking volume that it's placed on this case. Of course, that can be any actor. It could be any of these static mesh actor components. The ramps, the cubes, anything that's in the level essentially is an actor for the most part. And then once we've done that, we can kind of do a few things with it. So what we can do with the get owner is we kind of want to bind to some events so we know what's happened. Now, the actor component, or the actor itself, does have some event dispatchers on it. So if I just pull from it into bind, you can see all these different bind events that are available to us that are just on the actor itself. If you're making your own specific types of blueprint classes, you might need to cast at this particular point. Just remember though that if you are casting, then you're kind of limiting what this particular component works on. In some cases that's perfectly fine, but obviously it does reduce its flexibility a little bit. There are certain workarounds for it depending on what sort of thing you're trying to do, but it's just something to be aware of. Now the things that we're kind of interested in mainly are sort of the overlap events that we've got here. So the first one I want to do is, I'm just going to do the begin overlap. Again, you can kind of go a little bit, ham-bone on this. You can create certain conditions for all the different overlap type events, so even like the end overlap, and then have variables on the component itself that you can configure to change its behavior. So with us binding to that, we do need to specify the event that we want to call. So I'm going to do the create event, so you just pull from there, and then for the function, I'm just going to create a matching function, and that will automatically create a function with the relevant inputs for that function. So these inputs are what matches the event, well, the inputs on the overlap event, which is just something to be aware. So if you wanted to manually create it, you can do that. I'm just going to call this, we'll rename this to on owner overlapped. Like so. And then in here, obviously we've got some options we can do for this. We can choose to incorporate these if we wanted to. However, I'm not going to use those. Instead, I want to be able to specify the actor that's going to be destroyed when the owner of this component is overlapped. So I'm just going to create a new variable. I'll call this one linked actor, and that's going to be of type actor. Like so. And on the owner overlapped function, we're going to get the linked actor. I'm going to right click and convert that to a linked, a getter. So that's the, again, convert to a validated get. There we go. It usually helps if you use the right name. And that's going to essentially give us these, is valid pins or not valid. This is essentially the equivalent of doing this. So it's up to you which method you want to use. I like to just incorporate it. So it's up to you which one you want to do. So if the linked actor is valid, then we can just go ahead and destroy actor. Like so. And if we have successfully done that, I'm just going to clear the linked actor as well, and that'll just prevent it from attempting to destroy it again. In theory, it should clear anyway, due to garbage collection and things like that, but it just helps make sure that the reference is empty. Now, one last thing we kind of do need to do is just, on the actual variable itself, we do need to make it instance editable, and that will allow it to, that particular variable to show up in the list here when we have the component selected. So now what I can do, if we actually just go ahead and I'm just going to take this particular one, just move it over here. This is the one we've currently got it on. And with this component selected, the linked actor, we can use a little dropper tool, and I'm going to choose this little cube on the right. And then we do need to just double check the settings on here as well. So it is set to invisible wall, so it's going to block us, which isn't what we want. So instead, I'm going to do overlap only pawn, and that should update those other settings accordingly. And is there a way to make this visible? I'm not sure if there is. No, there isn't. So what I'm going to do, just so I know where that is, I'm just going to quick cube. This cube, its purpose is just so I know where the blocking volume is. Okay, so with that done, so we've got the actor component, we've got the destroy linker, and we've set the linked actor. So if we actually go ahead and test that, bam, it's gone ahead and destroyed it. And because of the validated get, that should hopefully prevent any of the access none type messages. Yeah, lovely. So yes, that's the particular component. Again, just an example. It doesn't particularly matter what it is. This particular cube that we've brought in, if I was to just go ahead and reset that, as long as we can overlap it. So again, I'm just going to come into the collision presets and just do that as overlap port only. And then we can add another destroy linker on there. And then this time we'll go for the left cube. And this time it's not done anything. Okay. So let's quickly figure out why that is. So we've got this here, so it should be functioning. So it does make me wonder if it's just an issue with the cube possibly not having collision. Let's have a quick check. No, so it does have collision, okay. So overlap pawn. Query only, no physics. Pretty sure that's the same. Okay. Yeah, it's also wall dynamic. Right, okay. So let's try and debug this a different way. So what I'm going to do is actually just open this up in a new editor window. And then I'm going to jump into the destroy linker. And we can see the two active components that have been created during play that are up here. So we want the one that's on the cube. I'm going to come and just highlight over here, add a little toggle breakpoint, and then we'll try overlapping. Okay, so that doesn't seem to be triggering, so that's going to indicate that possibly there might be an issue here with the overlap event. So what I'm going to do is add a breakpoint to this node instead, and we'll test. So it is jumping to it, okay. It doesn't seem to be firing it, so why wouldn't it be firing it? I want it to be an overlap. Try changing that to overlap all. See if that makes a difference. No. Okay. Try it with this cube. So again, we'll add the destroy link here. I'm going to link to that cube on the left. And I just want to make sure that, again, that's on overlap only pawn. Oh. We probably want to disable the physics on the cube. Right. That's also not working. That's still working. Okay. Of course. Generate overlap events is unticked, so if we actually tick those, it should now be working for both of them. So what I'll do is just set the white one to the far one in the middle. So that one, there we go. Then that one, let's just disable that breakpoint, but that's working now, and there we go. So as you kind of notice there, we kind of ran into an issue with the generate overlap events not being ticked. Now, we might be able to actually automatically sort it out. So let's have a quick look. So generate. It's not let us do it. We get the root. It might have to be the component. Generate overlap. No. Is there anything like it? I guess overlap. Oh, let's double check the exact spelling again. Yeah, just generate overlap events. Okay, so let's try that. So generate. Okay, so we can do that, but it's got to be a primitive component. So if we get children, I want to get child components. And then we can do a for each loop. And then we can cast to a primitive. Primitive component. Now we've done that, we can set assuming the cast is successful, so it is a primitive component, we can generate the overlap events. Like so. So what I'm going to do is on these two here, I am just going to untick those again. So now it's not ticked. And despite that, it should, I say should still work, but it's not. Okay. So it could be that there might possibly need to be a delay in there. Probably just till the next tick. Let's do include all descendants. No. It could also be that the root is also a primitive, so we might need to include it there as well. That itself could be the issue. And that's going to do both. Okay, yeah, so that does seem to work. So in this particular example, the root component was the one we needed to set it on. So I guess in this example, we could probably actually just remove that altogether. So again, if we test that, yeah, that's still working. And just as a reminder, the generate overlap events is unticked. But in this example, with the actor component, we are automatically setting that to true on begin play through the component itself. So hopefully that gives you a bit of an idea in terms of how you can possibly use actor components to create sort of more reusable logic. Again, you can kind of go a little bit ham-bone in terms of how you want to set this up. So again, you kind of choose how you want to do that. What we could always do is possibly just add a, so probably don't need the delay until next tick anymore. But we could always add a branch in here as well. Put that to a variable, call this one auto enable generate overlap events. Again, we can make that instance editable. So now on the destroy link, we actually have an option for that. So it'll be true by default. So if you don't want that behavior on, like you want to be a bit more specific in terms of what triggers it, you can always untick that. Again, so there's quite a lot of options in terms of being able to make these actor components super reusable and configurable. Other options that we can possibly have. So instead of actually doing it here where we have a destroy actor, it could be that we have a linked actor, but then we also have possibly something else that we actually call. Now, what I'm about to show next is probably kind of like the backbone, certainly for myself anyway, in terms of how I set a lot of my sort of logic up. So let me just sort out this here. I don't want to show C++ classes or engine classes or any of this actually. So it could be that we kind of want this particular actor, possibly, maybe even, just to be a little bit more modular in a sense that we can kind of customize it on the fly and do all sorts of other things. So what we can actually do, if we go ahead and create a new blueprint class, what I'm going to do is actually create an object. Now, ideally, if you have access to C++, in some of these instances, creating base classes for UObjects tends to be more desirable in C++, just because you're able to add world context if you require it. It's not essential. There's plenty of workarounds for not having world context in UObjects, but obviously for some people, having that access there tends to be a lot more convenient. So again, that's only something you can add via C++. But in this example, I'm just going to call it linker action. Like so. I'm going to open it up and I'm just going to create a function in there and call it run action. Just like so. Now in the linker action itself, that's pretty much done. There's not really anything else I want to do with that just yet. Well, I don't think there is anyway. But what I'm going to do now is actually jump back to the destroy linker actor component. And on this one, I'm going to go ahead and add a new variable. I'm just going to call this one linker action. I'd probably just call it action to be fair. And for the type, it's going to be of type linker action. You may want to do this as a soft reference. It depends on how you plan to handle it. Just remember, if you do use a soft reference, then you'll have to load it before you can use it. Now, this itself, I do actually want it to be a class reference, not an object. And inside the on-owner overlap, instead of doing all this stuff with the destroy, what I'm actually going to do is bring in that class, and I'm going to create, well, in this case, construct that particular object from the class. And then from there, and I'm going to call that run action function. Just like that. And we just want to make sure that the variable action is also instance editable. Again, this is just so that when we have it selected, we can choose what we want. Now, in the little drop-down link, we do have the linker action base class showing in there. That's not something we want, just because this particular class won't do anything on its own. So, under the class settings, we can go ahead and make it an abstract class. And then under here, it'll disappear. So we kind of have to, in this instance, create child of it. So there's kind of lots of things that we could possibly do. It could be that we have a linked actor and we always possibly want to pass that to the action itself. So in that instance, I'm actually going to come up to the run action, just add an input. So this may or may not be used depending on how it is that you're wanting to do things. Like so. That'll then show up on the run action user event, and we can just plug in the linked actor variable. Like so. So what I'm actually going to do now is go back to the content browser. I'm just going to right click on the linker action. I'm going to create a child blueprint of that. And this is going to be, just got LA, we'll call destroy. So this is kind of where we can get a bit more flexibility. So we'll go ahead and just open up the destroy, and I'm going to do the run action. We don't need to call the parent function, so we can go ahead and do that. And again, from the run action, I'm just going to call the destroy actor function. So now from here, we can actually select the destroy and change the behavior that this particular linker is going to perform. So in theory, it should still work. This one won't because we've not got an action signed up to it. We do have the events here flagging as invalid. That is most likely because of this here. Let's double check that again. Yeah. So on the destroy link, I just want to convert that to a validator get as well, the actual class. So it's only going to attempt to do anything if you've actually set a valid class. If it's not valid, again, you can kind of come in and set up some debug messages just to help you understand what's going off. Now with what we've set up here, we've instantly got a little bit more flexibility. So now we can actually come in, and on the linker action we can come and create another one, so another child. So call this one LA, we'll call it scale. And what we're going to do, again, override on the run, we don't need the child. This time we're going to set the scale of the actor, and we're going to make it double. Well, we're going to set it to 2. So for this particular one here on the destroy linker, which I guess we should probably rename something else, we'll set that to scale. Bam. And these two still destroy. But it might be you come in and you think, oh, actually I could do with doing that a little bit differently. You can just come in and just look through your list of actions. So one of these is now a scale. That's still a destroy. And there we go. So yeah, so you can kind of go through and create quite a lot of these individual specific actions, and you can go ahead and essentially set them up how you like. And there's nothing to say that you couldn't have it where, for example, because these are all going to be triggered through the destroy linker, which I'm just going to rename now to action performer. Again, you can think of different names, whatever you think's most appropriate. So when we actually construct these linker actions, we do pass in the self, so in this case the action performer, to the linker action object that gets created. So what we could always do if we wanted to, in here we can get the outer of self. So this is inside the scale linker object. And we can cast to the action performer. Generally that's what it should be. It could be that you decide to use these actions for other things as well. If that's the case, then you'll just need to take that into consideration. Now, there's nothing to say that we couldn't then set the action to something else. So in this case, I'm going to set it to the destroy. So once we scale something, it's going to come in, it's going to then set the thing to destroy, which means that when we then pass over it a second time, so that's going to make it big, and then we do it a second time, it's going to destroy it. So as you can see, we're starting to get quite a lot more flexibility in terms of how these systems are essentially being built, all because of this one actor component that we can easily just kind of like drop onto something. So we come over here, it's like, okay, action performer. Okay, this time I want to do another scale, and for the action, this ramp looks like it needs to get big. Now it's somewhere over here. Well, I'm not going to be doing that at all because I can't access overlap it, so quickly update that. Overlap only pawn. So somewhere over here, there we go, we've just scaled it. Again, super easy to do. We've created this actor component and we've set it up where we can flexibly update, change, and do whatever we want. Again, in terms of this particular concept, you can kind of go absolutely ham-bone on it. Again, create as many linker actions as you need for different things, and again, it could be for updating materials, things like that. Other things that you could possibly do is, obviously I'm not going to cover it heavily in this particular video, but if we create like a new variable, there is instance structures like this, which by themselves don't look like much, but you can effectively select any type of structure that's available. Let's quickly look at one that might make sense. Sphere 3D, yeah, there we go. So in this particular structure, there is a 3D vector and then a float, and that kind of allows us to then kind of set those values. Now, I do want to set that back to none. So again, if we kind of set that to instance editable, that does give us the option then to select that, which means that we could always have that then as on the run action instance struct, have it where we then pass that through as well. So that when we actually come to these sorts of things, we can kind of control. So let's say the scale, for example. We trying to remember the name of the function now. Instance structs, we want to get instance struct value. That's like so. If it's valid, we do want to connect that up like so. So in this particular example, it's going to attempt to set the scale to whatever the instance struct is. I'm going to quickly add it where if there isn't a valid one, it's just going to do it to 2, 2, 2, and then come back up here. So 2, 2, 2 is kind of like the default scale value. Yeah, I am aware that I've not actually named these variables, just so you know. So in this particular example, things should still continue to work as they were. But again, if I was to take this particular one here, I could then do vector 3D, I believe it is. And if instead I was to go for 3 by 3, I should make it really big. Is that bigger? Is that 3 by 3? No. Okay. So that means we've not got the right one. That's probably because we actually need, I think it's just called vector, isn't it? Is there one in here just called vector? Yes, there is. There we go. So now if we try that, there we go. So now we've got a 3. So using the instance structs can be kind of like a great way to pass additional data through to those objects that are used within the Act component. So yeah, so hopefully you found this video helpful. But as you can see, there's quite a lot of flexibility in terms of how you set these up. Again, in this example, I've just created 2 of the linker actions. You can kind of go hambone, again, call them something else that makes more sense to you. But yeah, so again, just want to say thanks for watching. Hopefully you enjoyed the video and have a great day. Take care.